The molecular formula is a formula that defines both the type and the number of atoms of a compound. Usually, we use the molecular formulas to write the balanced chemical equations and to calculate the molar masses. For example, methane has the molecular formula CH4. From this formula, we can say that methane has 1 carbon atom and 4 hydrogen atoms. Another example, butane has the molecular formula C4H10. By looking at this formula, we can deduce that butane consists of 4 carbon atoms and 10 hydrogen atoms. Now, let's move to the empirical formula. The empirical formula is a simple method to represent the ratio of atoms in a molecule. The empirical formula gives us information about the type of atoms in each molecule and their ratios, but not the exact number of each type. For example, we said the molecular formula for butane is equal to C4H10. The empirical formula of butane is the ratio of carbons to hydrogens, C2H5. You can see that we divided both the carbons and hydrogens by 2 to get the ratio of carbon to hydrogen 2:5. Another example is cyclohexane that has a molecular formula C6H12. To get the empirical formula, we divide both carbons and hydrogens by 6. So the empirical formula is CH2 with a ratio of carbon to hydrogens 1:2. We also can use the empirical formulas with ionic compounds. Actually, the empirical formula is the same as the ionic formula. For example, calcium chloride CaCl2 has the empirical formula CaCl2 with a ratio of calcium to chloride 1:2. And the sulfur dioxide SO2 has the same empirical formula SO2 with a ratio of sulfur to oxygen 1:2. Most inorganic compounds have empirical formulas similar to their molecular formulas. For example, sulfur trioxide S2O3 has the same empirical formula S2O3. But not all inorganic compounds have the same empirical formula similar to their molecular formulas. For example, hydrogen peroxide H2O2 has the empirical formula HO. We can deduce the molecular formula if we know the relative molecular mass of a compound and the empirical formula. Let's solve this example. A compound has the empirical formula CH2Br. Its relative molecular mass is 187.8. Deduce the molecular formula of this compound if you know that the relative atomic mass of Br is equal to 79.9 for carbon, is equal to 12, and for hydrogen is equal to 1. In this example, we know the relative molecular mass and the empirical formula, and we need to deduce the molecular formula. We will use the empirical formula to obtain the empirical formula mass of the CH2Br. 1 carbon with a relative atomic mass equal to 12 plus 2 hydrogens with a relative atomic mass is equal to 1 plus 1 bromine atom with a relative atomic mass equal to 79.9. The total is equal to 93.9. If we divided the molecular mass 187.8 by the empirical formula mass 93.9, we obtain the factor that was used to simplify the molecular formula. This gives us that if we multiply the empirical formula CH2Br by 2, we get the molecular formula C2H4Br2. Let's solve this example. Calculate the molecular formula of the compound C3H5 if you know that the molar masses Mr is equal to 82 and the relative atomic masses for carbon is equal to 12 and for hydrogen is equal to 1. Similar to the previous example, first we calculate the empirical formula mass, which is equal to 3 carbon atoms multiplied by the relative atomic mass of carbon, which is equal to 12, plus 5 hydrogen atoms by the relative atomic mass of hydrogen, which is equal to 1. The total is equal to 41. So the empirical formula mass is equal to 41. Now we know the molar mass is equal to 82 and the empirical formula mass is equal to 41. So if we divided the molar mass 82 by the empirical formula mass 41 is equal to 2, again we will multiply the empirical formula by 2 to get the molecular formula, which is equal to C6H10.